Hello, and welcome to this video on solving radical equations. I'm just going to do some examples here. The principles involved in solving radical equations are decently straightforward. One of the things that makes them hard, though, is putting them together in the right order. Anytime you're talking about solving equations, it really comes down to you can do anything you want as long as you do it on both sides and keep everything in balance. So the order is important. I really think seeing some examples is really kind of what brings it to light. There's a little bit of a trick because not all the answers you find really work. And it doesn't mean you've done something wrong. It means that maybe it's a null set problem, or in fact, you may have what's called an extraneous solution. And we'll talk about that in a second. Okay, a couple of things I just want to review very quickly here about solving radical equations. Very simple property up here is if you had the square root of x and squared it, you would in fact just get x. And that is something you should understand because squaring and square rooting are inverses of each other, so they undo each other. The next is how to expand a binomial. It comes up quite a bit, and so there's a skill that is repackaged as you're solving radical equations here. Okay? And it is if you have a binomial like the quantity L plus R squared, you need to realize that it is the left squared plus the left times the right doubled, which is 2LR in this case, plus the right squared. Okay? You should have some practice in that. It'll feel a little awkward when you're doing it with radicals, but it really is that pattern being utilized when you are in fact squaring a binomial. Okay, so it says, please solve the following equations. Check for extraneous solutions. Okay? So an extraneous solution is something that you wind up at the end of the equation and say, this is what I've gotten, but it actually doesn't work. It actually needs to be thrown out. So here we have the square root of 4, x plus 4 equals negative 5. Okay? Now the one thing you should see right off the top of the bat is you're really never going to square root something and get a negative. So that should smell a little funny right when you read it if you're paying attention. But I'll work it out using my properties of equality, and I'll say I'll square both sides to start. Okay? And that's going to leave me with x plus 4 on the left, and be careful on the right, you in fact get 25. So now when I subtract 4 from both sides, I'm just left with x equals 21. So when I go on my calculator, however, to investigate if this is correct, I'll do 21 store x. Okay? And then I'll type the original equation, which is second square root x plus 4. And then I'll actually use the test button here to get up the equal sign. That's hitting second math and choosing equals out of that list, then typing negative 5. Remember, when you hit enter, 1 means it is done, O means it is no, 1 stands for true, 0 stands for false. So my x equals 21 doesn't work. It's what's called an extraneous solution. So you need to realize that. And I'll just drag this in here for the record. Okay, so because you have one answer that is now extraneous, you cross it out and you say null set. If you had two answers and one were extraneous, you would only throw out the one answer and then that is extraneous and keep the one that's legitimate. Okay. So these examples will get a little bit harder. So if you notice here, we have a situation where we have a radical on both sides. So it says, please solve the following equations, check for extraneous solutions. Okay, well, my instinct tells me that I want to square both sides, and squaring the right side is not that hard. Squaring the left side will be. Okay, so you just need to realize that as I go back, I'll just do a quick copy paste of this property here, because if you notice, I in fact do have two terms that I'm squaring. So it follows this model. So I'm going to write L and R just to demonstrate it. My L, my left term, is negative 2 root x. My right term is 6. So when I square the left term, I'm going to get 4x. If you're uncertain of how I got that, do negative 2 root x in the margin squared, which just means you're going to square the negative to get a positive, square the 2 to get a 4, and square root x, which gives you 4x. Okay? A couple times writing that in the margin might allow you to see what you need to do. Now I'm going to do the left times right times 2. That's going to give me negative 12 root x, but I'll double it and get negative 24 root x. And then I'm going to do the right squared, which is coming from the right being 6, and then squaring it gives me 36. And then on the right side of the equation, I just get x. Okay, well, I've moved forward because if you notice now, I started with 2 radicals, and all the equation seems like it's expanded and bigger. Now I only have 1 radical. Okay, well, if I can isolate that radical and just get everything other than the radical for the most part on the other side of the equation, that might be something that's good. So why don't I do this? I'll subtract 4x, and that's going to give me negative 24 root x plus 36 equals negative 3x. And then I'm going to subtract 36, and that's going to give me negative 24 root x is equal to negative 3x minus 36. Okay? And I think for now what I'm going to do is just divide by negative 1 so that it'll just help me with my signs being all positive. If you don't see that, it's fine. It makes it a little easier. Okay. So now, what is it I need to do? Well, it would seem that getting rid of this radical, again, by squaring both sides, seems like a good idea. And again, if you notice, on the right side of the equation, I'm in fact going to need this principal again. Okay? So the left side, we're going to do 24 squared. I have no humility when it comes to going to my calculator for a number like that. Okay, so it's 576x. Okay? And then we do left squared, left times right, doubled right squared. So it's going to be 9x squared. Left times right, I think is 108x, just to make sure. Oh, I'm so sorry, 3 times 36. 3 times 108. It's going to be 108, but then I'll double it. So that's going to give me 216x. And then 36 squared, probably a good time for my calculator as well, and get plus 1296. Now, if you notice, this is a quadratic because the degree is 2. So I'll just try and set it all equal to 0 and look to factor or use the quadratic formula. So I'll probably subtract 576x and wind up with 0 equals 9x squared, 216 minus 576, and then that's negative 360x, okay, plus 1296. These numbers are obnoxious and large. Might be a chance to, if I could, well, if 1296 is divisible by 9, and it is, that's good. So I actually could divide this entire equation by 9, it looks like. And I'll do that, and that's going to give me a little simpler before I go to the quadratic formula. I'll get 0 equals x squared minus 40x. And off my calculator, 1296 divided by 9 was 144. I actually might even want to see if I can factor that first. So are there factors of 144 that make 12? Well, a little trick on your calculator for that is to do 144 divided by x in your y equals window and go to the table, because then you could just look real quickly and see, does any of that come out to be 40? So I won't even need the quadratic formula here. I'm so excited because I made this problem up and had no idea it would come out this nicely. So I actually can do what? 0 equals x minus 4, x minus 36. And then using the zero product property, instead of the quadratic formula, I would get 4 for x and 36 for x. I don't circle them yet, however, because I need to check them on my calculator and see if they in fact both work. So to start there, I'm going to go with 4 store x, and then type the original equation, which is negative 2, second square root of x, plus 6. And I want to know, is that equal to the square root of x? Excuse me, second test equals second square root of x. 1 is done, O is no. That answer actually works. So probably a good time to come down here and circle the 4 and include it in the answer. Okay? And then checking for 36, is 36 store x? And I can do second enter twice to bring back the previous line. And looking for a 1 here, but it says 0. So this answer I found is not actually going to make the equation true. So although I found it, I'm throwing it out Okay? I'm decently confident if I got the other one to work, I really didn't do anything wrong, so getting to this wrong answer was actually correct. It's not that it's wrong, it's that you're correct to say it should be thrown out because it doesn't work. There's nothing wrong with seeing that if that's in fact what is going on. Okay? So I'll just pull that into here in case I want to refer back to it. And just a quick overview of this problem. I show the whole page. This was a little different than the first one because the first one only had a radical on one side. Decently easy. If you also notice the left side, the only thing there is the radical, which then when I square it, just kind of follows this principle of canceling that radical. Okay? So we're going to solve the following and check for extraneous solutions. Square root of x minus 4 plus the square root of x plus 3 equals 4. Now, if you notice, here I could very well start with square both sides. Okay? But if I do, I'm going to need to do left times right doubled. You see that from the previous video. And that's going to be a mess. Okay? So I'm actually not going to do that. Okay? So what I will do is be clever here. And I'm actually going to subtract one of these radicals on both sides. That'll split the problem where both sides will have a radical. And now if you notice, this quantity in the next line, when I go to square it, will only have one radical in it, and it'll be easier. So let's write the result. Square root of x minus 4 is equal to 4 minus the square root of x plus 3. Well, I will, in fact, square both sides. Okay? The left side should be decently easy. It's this x minus 4 is equal to, and now when I go to square the right side of the equation, I'll look at my L and R model and do L squared, which is 16, L times R doubled, which is negative 8 times a quantity, root x plus 3. Okay? And then my right squared becomes a positive x plus 3. Okay? So now I'm going to just do a quick combine like terms. Take my time so I don't make a mistake. I've got 19 minus 8 times square root of x plus 3 plus x. And then I'm going to subtract x from both sides, which is really nice here because it will cancel both those terms. Get negative 4 equals 19 minus 8 times the square root of x plus 3. And then I'm going to subtract 19 from both sides and get negative 23 is equal to negative 8 root x plus 3. And then now it seems like as good a time as any to be able to square both sides. So I'll go to my calculator. Excuse me, got to make sure you have parentheses for the negative 23 squared. That's going to give me 529, which is equal to 64 when I square the negative 8, and then just x plus 3 because the root gets canceled. Okie doke. Then I'm going to get 529 is equal to 64x. Then 64 times 3 is 192. Then I'll subtract 192 from both sides. 529 minus 192. I get 337. It's equal to 64x. Divide by 64. And get x equals 5.27, we'll call it. Okay? So now when I go to check the problem, I'll use my store button, but I won't use the test button because I've rounded. Okay? When you use the test button, the answers have to match identically to do the 1 is none, O is no trick. Okay, which is just your true false. Store x. Okay? Pop it into the original. Second square root of x minus 4 plus second square root x plus 3. And again, it says it's equal to 4. I'm hoping for just very close to 4 because I rounded my answer, and I think that's pretty close to 4. So I will call this a legitimate answer. It's only one answer. There are no extraneous solutions here. Okay? So feel free to rewatch this video and the other video that led me here before I made the mistake, depending on how I edited all this together. Again, the problem here with this problem is that you're starting out with two radicals on one side. So if you were going to square that all to start, you'd have a mess. Just a little step of being able to split your radicals doesn't always work. Try it out. Sometimes it works. Here it works great. These problems, I can't reiterate enough, they all revolve around you can do anything you want as long as you do it on both sides. It's just a little trickier to apply when you're talking about squares and square roots and multiple terms and things of that nature. Okay, enjoy.